I don't know why every single time I look at this black cabinet, I think of Back to the Future. Insert video clip now, BBI.
Of course, from a group of Libyan nationalists. They wanted me to build them a bomb, so I took their plutonium and in turn gave them a shiny bomb casing full of used pinball machine parts. Come on, let's get you a radiation suit.
What should I say? Easier than I say. Oh, God, I know. Okay. Well, it's now evening. And I need to take a little bit of time. I need to look at this and figure everything out about it. Thank God I know a guy, right? Okay. So I'd assume, based off the labels, this is our master power. This is going to be our high and low tap. So let's see, that's off. So this is going to be our high voltage control. Bet you when we turn this on, excuse me, Tesla. Let's see, what do you go to? Okay, so you go to ground. And these two leads. Let's see here. Yeah, they go to the primary on the plate transformer. Oh, got an electrical ground and an RF ground off the transformer. I dig that. So this thing was built by my friend, Smokestack. I don't know my friend. I met him one time and we've talked on the phone, and he's a very kind person, good guy. He's been around for a hot minute. Smart dude. Larry loved glass. I'm not a big fan of glass. It's not that I'm tired, yo. It's just been an incredibly hectic day. So we don't have a roll counter on this. Of course, we don't really have a tune load reference number on this either. Not that that matters. So it's going to be our blower, it's going to be our filament, it's going to be our keying circuit. Input tune, output tune. And we got a grid meter, yo. A lot of guys today don't understand it's one simple resistor that goes from, yeah, that's all it takes to run that. High volt meter, current meter for the plate, and a grid meter. That's awesome. This knob here. Oh, so this is a Variac that's back behind here. Variable tap transformer, right? And what we use that for is to turn the voltage of the filaments, bring them up really slow. So we could start all the way down here. Let me verify that this is actually wired the way I think it is. I mean, there's really only a couple ways that you can wire this. This is what I learned from my buddy 7. way back when I was a young man. I'm an old man with a gray beard. Let's see, so the white wire comes off and it feeds. Where do you go, white wire? Oh, see, green, white. The white goes up, comes over, and it feeds. Over here to the primary side. Okay, so that's all the way down. So instead of having a soft start circuit on the filament, you guys have seen me build filament or soft start circuits for high voltage, the high voltage section of this. I haven't even looked to see if it's got a soft start circuit in it yet. This is just, I'm talking about the filament. Bring the amplifier on, you engage your filaments, and to help minimize your current draw when it first starts and also help minimize the inrush current draw of the tubes, you can bring this up really slow. And I have a feeling that this yellow mark is right about appropriate for the voltage for the filaments. And then this is going to be maxed out on your filament voltage. When you reach the maximum on the filament voltage, I'm pretty sure the tubes would be at the end of their life based off of this knob. Does it have a soft start on this thing? It does. Look at that, mounted right down here on the floor. Alright, so it's going to be our low voltage supply. Boy, Smokestack, I got to give you credit, homie. You're not screwing around when it comes to the high voltage wire on this thing. He's got 100 kV high voltage wire on the inside of this thing. It's actually got new modern capacitors on it, believe it or not. Wow, this thing's surprisingly put together well. It really is. How many amps a breaker? 40. Okay. I think it's time for you guys to get to look at what I'm looking at. What do you think? Let's take the camera around to the other side of the box. So we'll start here on this amp. Please note, it does have a closable door on the back. I don't think what modern amp builders know what this is. Seems like everybody's got to build everything in an aluminum cube. Okay, so everything's just de-energized here. We're going to point at stuff. We're not going to really put our hands upon it. Okay. You know what? Hold on one second. We're going to do this. Even though the meters show it's dead, let's make sure it's dead before we go in here and start sticking our man touchers in here. We'll go in here and we'll touch here. We're going to touch here. And touch there as the top side. We'll go in here. We're going to ground this out. Okay. So now we know it's dead. We're not guessing. We know. So we'll start at the bottom and we're going to work our way up. Come say hi to everybody. Oh, you want to say hi to everybody? Hi. That's my Tashdaboo. Remember when he was a puppy about, what are you, about 6 now? 6, 7? Yeah. That's my boy. He's like, dude, I'm just chilling with Dad. I don't give a shit. Okay, so here's our soft start circuit. This is our primary breaker. It is braked. It's got a 40 amp breaker in it. So our 220 volts come in on the black and white. Green is ground. And the color code stays consistent throughout the cabinet. If you see green, yeah, we're seeing ground. Anyhow, for our high voltage to be activated, we flip the switch on the front and let's see. This first contactor closes, and then this secondary contactor closes, and that brings on the second side of the plate transformer for the high voltage. This is our filter bank. These are our rectifiers. These are commercial grade rectifiers. Where did I put the paintbrush? You gotta remember, guys, that this thing's been sitting for 1.5 years Just waiting for somebody to come along and say, hey, we still love you, right? This is our high volt primary side. Look at the size of that high volt lead. And it wraps around and it goes up here. Shows up here in the RF deck. We have a decent Sprague doorknob, our bypass cap. This is our plate choke. That is our tank coil. That is our glitch choke. This is our transmit keying relay. And our input relay is inside. I think. Pretty sure. These are our filament leads. They come from down here. Wow. Geez, Danny, you did a good job, man. Really did. When the door's closed, you can have access to the input, output, and then keying circuit. Gotta remember, kind of low voltage, kind of high voltage. To a lot of guys, this is high voltage. To me, this is relatively low. You only have access to this little portion here. You can't, without being really stupid, stick your hands in here and go for tilt broke boogie. I don't see anything in this that makes me have pause not to want to plug this in and try it. It's our blower. Of course, I want to measure our filament voltage. I want to watch the variac work. Let me take you to another point of view here. It has a clear plexiglass lid on the top. And this is how we get the tubes in and out of the RF deck. We cannot physically get the tubes to slide in here from the back and up and in. They won't make it through this opening. So what Stack has done in his infinite wisdom is built it so it's got a lid on the top. This allows us to have access. There's a little Jennings vacuum variable here, which is to the plate, which is where our highest kV is going to be, highest load. And the air variable is to the antenna, which is the load. Truly monoband, so we don't need to worry about parasitics. But this is as straight up can get. 2-tube, man. 4-1000. Well, let's see what we got going on with our tubes. Let's jump over to that. Pentalabs 4-1000. I'm assuming this is a backup tube. This thing looks brand new. We're all familiar with our friends at Pentalabs. Anyhow. This has a spot for 2 more tubes in it, but I think that this old school iMac will eventually find its way back inside the box. So will this. This is also an old school iMac. What people do is they make the mistake when they get one of these tubes, and they'll take like Windex, which is horrible, by the way. It's horrible on window tint and it's horrible on tubes. Or they'll take some kind of automotive glass cleaner. They'll spray it on the glass, and then they'll take the rag and they'll lay the rag in their hand, and they'll take the tube and they'll spin the tube, and then they'll come back and they'll be like, what's this red smudge that's on the towel? And it'll be all the paint off the tube. Just ruins them. This is the most elaborate case to hold these tubes like ever. I love it. I can't remember if I said it in the opening segments or not, but this really, it does remind me of Back to the Future. Well, let me get my brain up to speed with the 4-1000. I haven't looked at the data sheet for the 4-1000 in, It's been a general minute. And FM broadcast service on 110 megahertz. 2 4-1000A. Tetrodes will deliver usable power up to 5,000 watts, so 5 kW. Continuous. It's continuous operation, by the way. So we can overclock that a little bit. In Class AB1, a pair of 4-1000 triodes will deliver 3,000 watts of useful power. Okay. Let's see, filament tungsten, basically a light bulb. We're looking for 7.5 volts. Okay. So 20, minimum 20, 22. So we have a 2.7 window, 2.7 amp window. Let's go down here. 6K. All right, well, it's all right. Screen 1,000. Okay, so 700 mils per tube. So we're about an amp and a fourth. So 1.4 amps. So 5,000 volts, screen 500. So about 500 mils to 200, and that's not bad. Apparent drive power increases in increments. Drive power requirements increase above 30 megahertz at 110 megahertz. Driver okay, radiation. We're not using this as an audio frequency amplifier. That'd be awesome, though. I would love to build one of these as the final stage of a guitar amplifier or something. Imagine what 4,000 or 5,000 watts you can do with a guitar amplifier. 4,000 or 5,000 watts. That's pretty neat. If we put it in AB2, it's going to make 4,000 watts per tube, roughly about 3,900 watts per tube. Okay, G1, G2, F, filament 1, filament 2, so pins 1 and pins 5. So it's going to be 1 and 5, they're going to be right next to each other. All right, so then G2, G1, G2, so these are internally connected. So pins 4, pins 2 are going to be shorted across through the tubes. Pin 1, pin 5 is going to be our filament, and pin 3 is going to be, okay, our screen control, no big deal. This is easy. It's easy now that I understand what all this is. Easy peasy. The main thing that I need to look for on startup, when I probe out the filament, is going to be the 7.5 volts. I want to make sure that we have that present. And then we will probe the high voltage here. So first thing we're going to attach to is pin 1 and pin 5. Let's go check our filament volts. Okay, so over here we have our voltage. We are hooked up to pin 1 and we're hooked up to pin 5. This is our master arm switch. I'm going to turn that on. So we have no action, nothing's going to take place. Now, in the ideal world, what you would want to do, if I understand everything correctly here, which I'm pretty sure I've got a fairly decent operational grasp of what's taking place here, you would always want to turn your filament on first. Your filament comes on first and is the last thing that you shut off. I mean the fan, pardon me. Then you're going to bring your filament on. So we can see now we've got a little bit of reference voltage over here. Come around the other side of the tripod here. So if we grab this variac down here and we start turning it, we should see the filament voltage increase. Now under load, we're looking for 7.2 volts, which is going to be probably somewhere right about in here. It's pretty close. So on the yellow dot itself is 7.8 volts, which is perfect. It's right down the middle of the butter zone. So maxed out is 8.42 volts on the filament. Of course, we're looking at this in AC, so we'll turn this back down. We don't need to worry about that for right now. All this switch is going to do is allow you to engage your foot pedal. So operate and standby. No, there is no auto key with this. You'll end up burning your relays up. You don't want to even deal with that. So let's go ahead, we'll shut our filament down, then we shut our fan down, then we shut our master off. Please note, this light indicates filament on. This light here, or fan on, indicates here. Filament indicates here, and I can almost bet you money that this is gonna, when we go to put this into operate and we step on the foot pedal, this light will come on. All right. Let's make everything safe. Now let's get out the high voltage probe. Get ready to probe the high voltage, and I can't help but notice that the sockets, when we turn the fans on, threw out quite a bit of dirt. There's I wish I could tell you the whole story of this thing. It's been made safe. We've grounded everything out, and we've unplugged everything. So it's an inert piece of metal at this point. I wish I could tell you the whole story behind this and all the different things it's been through and the story that goes on with this, but I don't know it all for really. I have a fairly good idea what's gone on here, but for right now I know that I need to get a vacuum and I need to get down in here and I need to clean out these sockets, because there's quite a bit of lint and stuff inside the sockets, and I don't want to have anything blowing around in here that we don't need to have. So give me just a minute. We're going to get out the handheld portable Ryobi/R2D2A, and let's go to work. Just took the leaf blower to it, then the air hose to it, and vacuumed the entire inside of the deck out. This thing's been moved around quite a little bit in the last few years, and it's, yeah. All right, so let's be smart and let's be safe. Yep, that looks good. This all looks good. That's grounded. Contact. Okay. So 3,339 volts indicated here on low. That's how we get to high volts. This thing's going to jump. 6,000. This reads, yep, spot on the money. 6,800, and this is reading 6,005. So we'll drop this down to low. Bleeders work really well. Now we're back down to 3,000 volts, and let's pull all the high voltage out of the deck. This was in a garage at one point, then it was in a shed at another point. It was in a storage unit, and I'm not saying this in order for a reason. This has just been moved around a little bit. So it doesn't surprise me there's little pieces of grass and lint and dirt on the inside of the thing, right? But there's not now, it's all been cleaned out, right? What we're looking at is the bleeders, how fastly they're going to pull the high voltage out of the circuit, which is relatively quickly. Good job, Danny. Really good job, Danny. It's 500 volts, 400 volts, 300 volts, 250, 220, 150, 100. 45. $29.10. Okay. Now it's time to bring on the tubes, which, yep, we'll reset this to 0. Last couple volts are a little hard to get rid of. It takes a little bit of time. That's okay. His stack is worth his salt. He's got a fairly decent glitch on this thing, which so far, Danny has proven himself to be that kind of man. It's not dead until it's grounded and dead. Okay. See how that popped back up? It's only like a volt or two. We'll go back here, we'll open the cabinet, make the cabinet safe again. Reattach our ground. Reattach our ground. And we'll bleed it off completely now. All right. So for safety reasons, now we go ahead and we go that extra step. Now that we know it's completely neutralized, we unplug it from power. Okay, the reason I made such a big deal out of verifying what the voltage is doing is because this is no effing around time. This isn't the time that we play. This isn't when you have your 5 friends over and you have a couple beers. You need to kind of focus up here and just have a quiet little moment of zen as you're doing this kind of stuff. It's like I've waited until the evening, everything is put away, phone is off, focusing, okay? My biggest pet peeve when it comes to tube amplifiers are people that put the tube in and then spin it, looking for the holes. These pins are huge. They have a pattern. The pattern is there to help you out. If we notice, this socket has a pattern. We want to try and keep this as roughly oriented as possible. We really want to keep the jiggling of the tube to the minimum here, yo. And we're just going to do a nice steady amount of pressure and just wiggle it down into the socket and seat it. You don't want to slam it in, you don't want to be mean to it. This isn't a time to flex out your manhood and say, ooh, look at me, I'm a tough man, and slam this in the hole. That's not what we're doing here. We very nice and gingerly, softly, tenderly put the tubes in. Because remember, they are glass. Okay. Here's our chimney. Chimney number 1. I'm going to put it on this tube here. Going to make sure our finger stock is on the outside of the glass. The weight of the chimney holds it in place. Some amplifiers, the finger stock is so stiff that you literally have to listen to the finger stock go eek onto the glass. It's not necessary. You're not going to move that much air by the tube till we have to worry about the tube lifting up. We're not driving around in the mobile with this thing, right? That stock over, stock's on the outside, everything's good. Take our high volt leads, we're just going to lay them down in between the glass. Now we're going to close the lid. Now to verify, let's see, is there a place that I can jump onto the, there is not. Okay. Let's, there's got to be a way for me to get a probe in there. This is going to require, yep, hold on a second. Okay. Everything is recording. All right. So, indicated here, right here, is our filament volts. And then on this other camera, we'll cut over here. This is our amps. Whoop, hold on. That's our amp draw. So, we're going to go ahead and we're going to bring high voltage switches down, master on, fan on. Filament set at 0, filament on. So let's go ahead. Let's start lighting up the tubes. Here we come. There's 5 volts. Where are we at with our amp draw? We're about 40 amps. Let's get on up here and let's trim this up to the yellow dot. Spot on, Danny. Okay, so 7.24 volts. 45.4 amps. Well, I'll be diggity dogged. Let's back this down just a little bit. So where are we at with our amp draw? 44, 43, 42, 40 volts. Or 40 amps, I mean. Let's cut back over to the filament voltage. 6.2 volts. We'll bring this on up. 7.2. All right, now let's take a minute and let's look at the tubes themselves. We are operating. They do not. Go ahead and we'll shut the filaments down. Take the variable and we'll run that down to 0. We're going to let it do its thing for a few minutes. And then we're going to bring the high voltage on. I'm going to go ahead and I'm going to stop this camera because we're right within spec. We're at the edge of spec, but we are still within spec of what the tubes are supposed to do, which is good. That makes me happy. All right, so now let's go ahead and pull this out of here. Shut that off. Let's let this sit here and run for a minute. I want to let the tubes cool off. What we were basically just doing was what we call the air bottle test. I wanted to see if the inside of the tube has lost its vacuum. And how we know it's lost its vacuum is, well, just like on a 3500Z, if you turn it on and the filament, which is tungsten, has access to oxygen, it will fill the bottle up with white smoke. It'll fill the tube, the inside of the tube, up with white smoke. So, okay. I think we had the tubes on long enough to even worry about heat. I am correct. Shut the fan off. Shut the master switch off. Shut the breaker off. Let's unplug it. And we'll bring the high voltage on board. Okay, so here we stand. The filaments are on, the high voltage is off. And we got to let the tubes just kind of, we're just going to let them give a minute. That's all we're going to do. We're not going to get in a rush. They're going to sit here and they're going to run for a few hours, probably 3. You know, the tubes have moved around a lot. I want to have the best possible chance of success. So we're not going to get in a hurry. There's really nothing else I want to double check. I'm just going to burn some electrons. Our idling temperature is nice and cool. We'll close a little plexiglass top. And we're just going to take a break for a hot minute. I'm going to go probably have some dinner or something and just relax for a few minutes, and we're just going to let this sit here and idle. Some people believe that this is absolutely necessary. I don't believe with the glass bottle tubes that you need to cook the tubes in like this. Some people believe that it is not necessary. Some people do. With the ceramic tubes, like a 3000, those kind of things, they've been sitting for years upon years, like they're new old stock. The theory of new old stock, if that's really such a thing, yeah, you want to cook those tubes in for a long time. These were on probably 2 years ago, the last time. So we're just going to let this sit for a little bit, make sure everything is perfectly stabilized. There's no free roaming little bits of anything that's come out of the getters from them sitting all this amount of time. We're just going to let some heat get in everything, let the transformers kind of get used to having electrons present on them. And when we come back, we're going to hit it with some high voltage. We're going to start out on the low tap, go to the high tap, and then we're just going to sit here and we're going to watch it. And then we're going to do the scary bit. And the scary bit is when you step on that pedal for the first time. Okay, so we've given this a little bit of time to normalize. Let everything just kind of normalize on the inside of this thing. Let's go ahead and let's give ourselves a fold the glove over about 4 times. We have no current draw, and we're idling at about 3000 volts, 3200 volts. This whole upper section up here is now a death zone. We don't take and open this lid or stick our hands in there for any reason until this has been down to 0 for a long time. You don't do it. There's no reason for us to put our hands in there at this point, right? So let's give it a little bit more time just sitting here with this amount of voltage sitting on it. And more, this is me getting comfortable with the piece of equipment than I am saying that this is necessary for safety. It's just me. Okay, so I'm all set up over here for the next test. Got our resonant length of RG393 set up over to the watt meter. But before we can go that far, we've got to establish 0 signal. So we're on the low voltage setting. I have the foot pedal hooked up, and what we're looking for is about at the 3000 volt range. What we're looking for is this thing just to come up just a couple little boxes. Because up to here is 1 amp, right? Fully over in the corner, or full deflection of the needle movement, is 3 amps. Well, even at, I don't want to say the wrong thing here. It's not like I'm working with a 3000 or anything. I mean, fully loaded out, each tube's only going to pull maybe about 1 amp, if that. So we'll flip the switch to operate. 5, 4, 3, 2, 1. A little bit of needle rise. And by the way, that's on the mall button, straight up transmit button. Okay, so now we've demonstrated to ourselves that we're not going to spontaneously combust. Now we're up on the high volt setting. Now we're going to see some dramatic movement of the needle. Okay. Now we got grid current, and now we got plate current. Sweet. Okay, let's move on to the next thing. Okay. I'm encouraged by what I see. We're on the high volt setting here. And we're going to go over here. This is a 50 watt slug in reverse between the bench derail striker 955, which is here, and the dual tuber. This thing wants to run, wants to go. This thing here is a 1000 watt slug in peak. This meter here, 1000 in peak, 1000 in average, 5 watt slug in reverse. Now right now, Where did you come from? Come out of there, little guy. Man, we're just sliding downhill here, aren't we? All right. All right. So, 5-watt slug and reverse back from the dummy load. 1,000 watts going forward and averaging 1,000 at peak. So our pass-through tune, it's not the greatest. I'm going to have to come back and work on that, but we're not too worried about that right now. Hello, 1 2 1 2. Hello, 1 2 1 2. Hello, 1 2. Okay, so the average, we're looking at about 80 watts worth of drive because we're down on 12 volts over here. 12 volts on the striker. But check this out. Hello, 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 hello. So let me back this out a little bit. Let's make sure if I reach through, okay, we're good. The reason I gotta make sure I can reach through is because I want to adjust this down to nothing. So let's sit here and play with this for a few minutes. Hello. Okay, so the input tune is completely flat. Hello. Now we're over 1200. Hello. Hello. We're hitting the stop peg. Boop, boop. And we're bouncing back. Hello. Hello. All right. Hello. 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 See, am I blocking your view? No, I'm not. All right. So let's go ahead and turn the radio up a little bit. Oh, wait a minute. I'm plugged into that power supply. Hold on a second. Let's turn the voltage up on the workbench. Okay. Oh, now I'm starting to see the appeal of this. All right. So we've turned the derail striker up. We're now on 15 volts. We're still in the 1,000 watt scale. And remember, with the 60 to 70 watts worth of drive we were putting into it, we're getting around 1,000. So here's the radio again. Hello, 1 2, right at about 100 watts. 1 2 1 2. Watch this. Goodbye. Hello. So we'll go ahead and we'll flip this over to 2x. So now when the needle goes all the way to the right, we're at 2,000 watts. Hello, goodbye. We're well over 2,000. I think we're going to need to put a bigger slug in the front of the 43 for a change. Imagine that. So, hello, 1 2 1 2. With 120 watts of drive, we're making 2,500 watts without even breathing hard. Our grid meter is showing us, hello, 1 2, barely at 200 mils, and our plate amp draw is, hello, about a half amp. Hello, and the power supply on this thing is stiff. It's barely moving. Check it out. Let's come over here. Hello, 1 2 1 2. Hello, 1 2. Oh, this is going to be a fun one. Okay. All right. Let's grab the bench 2 pill and let's get that set up. Okay. So I got the bench 2 pill set up. We're back down on 1x. So we're on the 1,000 watt scale. Right. Whoa, right there. Okay. Hello, audio. So now we're going from 120 watts worth of drive to about 400 plus watts worth of drive. I just flipped it down into 5X. I haven't gotten to tune the load out, nothing. We're just gonna run into this dead. So, well, that's over 5,000 watts peak. Like gone. Hello. We're giving this one hell. Time for the 1,000 to come out. Time for that 1,000 to come out. Let's grab our 5. Let's grab our 10. So, 5,000 watts, 10,000 watts. Put that back in 1. So, all right. Oh, now if I don't show that silly little reflected bird slug there, somebody's going to call foul. Okay. All right, I can play with the amplifier and not getting in the way of anything. Hello. Holy shit. 7,000 peak. Hello. 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 Jesus, Danny. Good job, buddy. 450, 500 watts worth of drive is making 7,000 watts peak, and the input tune is spot on the money. Check this out. Hello, 1, 2, audio, 1, 2, 1, 2. Hello. Hello. Half a watt worth of reflect. I love my job. I love this life. Thank you guys for letting me have it. Okay. Right now, you guys have just sat through probably about a half an hour worth of ad-free content. That's unheard of in today's YouTube world. There are no ads in the middle of my videos. I've taken that limitation away from YouTube, and it's going to stay that way because of these people, the fine people here, right down here on Patreon. Right here on Patreon. The Patreon supporters are what allow me and you guys to be able to enjoy this kind of content without being interrupted by stupid ads. That's just one of many things that they do. And now that you guys are, we're sitting here, we're talking about stuff, I've got to go over here on this here. And I got to remove the ads from this particular video, save that. And then I put a couple videos out today, so now I've got to go over here to the dashboard while you guys are sitting there looking at the meter. If I don't do it now, I'm going to forget about it. And I got to take the ads away from these guys here as well. YouTube treats us, the content creators, like garbage. Unless you're like getting 10 million views a day, YouTube treats us like garbage. They don't pay us for anything. I get somewhere between 7,000 and 10,000 plus views a day. And I don't need their money. I don't want their money. I don't need their money at this point. These fine people here at Patreon, which are made up of people like you, are the reason that you guys have been able to sit here and watch content like this get created. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Get content like this created without ads because of them. So if you want to show some support, come over and join the Patreon group. We'd appreciate your help. I want to go look on the inside of the box and see what this thing looks like when it's running with 6,000 watts. What do you guys think? I don't know what the RF is going to do to the camera, if anything. I have no idea what the RF is going to do as far as the wireless microphone. But we're right next to the final stage, and we're getting 6,000 plus out of this thing. Hitting it with a 2-pill. So let's see what happens. Ready?
Hello. 1111111. Hello. Oh yeah. 1, 2, 3, 4. These are transmit tubes, and they work a little differently than other transmit tubes. No, they're not getting close to melting down. This is the way they're supposed to look when they're in operation. Hello. 1, 2, 1, 2, 1, 2.
I could tell just looking at the signal bars on the camera that I was just destroying the receiver. Believe it or not, that's exactly the way those tubes are supposed to look. We haven't even really started driving them that hard yet. I want to go to another level. Do you want to join me? Let's go there. Okay. So now I got the bench 2-pill set up. Or the bench 4-pill, I mean, set up. Let's zip in here and let me show you drive. Hello, audio, 1, 2. We're going to put about 800 peak into it, which is almost double the drive that we had going on before. So, pull the 1,000 out, put the 10K in its spot. All right. This is our 5K that normally comes out of this hole, and that's the 1,000 watt slug that's normally in that hole. And as you guys can all clearly see, and this is where stuff's going to get weird, okay? You know what? I'm going to have to take the camera off the tripod. Hold on a second. Okay, you guys, I'm going to do the best I can to not make you get sick, but you and we got to go for a ride. The reason we got to go for a ride is because everybody's going to say I'm faking what this box does. So let's come off the tripod. Let's come around here to the back side of the box. The back side of the amp. Here's the 393. Here's the 400 from the driver. So, let's come back around over here. Sorry about that. If I didn't show where all the lines were coming from A to B to C to D on this deal, there's going to be some weak-kneed keyboard warrior out there. Oh, he doesn't know what he's doing. Okay. So now we can see everything. So let's start over here. Right now, I've got a 1,000 watt slug in there going in forward position. So, hello, 1, 2, 1, 2. That's with the derail striker going into the bench 4-pill. We're getting about 400 or 900 watts. Now I'm going to make some adjustments on the workbench. That means I got to pan out. So we're going to pull the 1,000 watt element out. We're going to set it right there. And the first thing we're going to do is we're going to pick up this 25 kW element. Okay. We throw this in the hole. So let me zoom in on that. I want to show you what the difference of slugs means, the difference of the elements. We're going to start with a 25,000 watt slug, and we're going to show you what it's going to read on the 25 kW slug. So keep in mind, we're now reading that top scale. Okay, the 5 is 5,000, the 10 is 10,000, the 15 is 15,000, the 20 is 20,000, then the stop peg is, well, not the stop peg, but the end of the meter scale is 25 kW. Please note, I haven't flipped any switches on the meter. Nothing. Nothing and nothing. We step on the pedal. Hello. showing about 12,000 peak. And quite a bit in bird. See, what would that be? 3,000-4,000 in bird. Okay. Once again, we're going to make an adjustment. So it's back out here where you guys can see everything. We're going to pull the 25,000 watt element out, and now we're going to go back to the 10,000 watt element. Okay. So based on your element that you have, there can be a little bit of fudge factor that goes on. So now we've done all of our previous measurements with a 10,000 watt element. This is and hold on, let's get that reflect in there, because if I don't show that reflect meter, they're going to be like, dummy's load's all messed up, even though it's been certified and we've showed it, where we got it from, how we rebuilt it, everything. Thank you, Tony at Fat Boy, by the way. This was his personal dummy load that I bought. Anyhow, the 10,000 watt slug. So now when the needle goes all the way over to the edge of the scale on this side of the scale, we're at 10,000 watts, okay? Same amount of drive. Hello, audio. Hello. Please note the bird meter hasn't moved, but the peak scale is 10 grand. I can sit here and I can fiddly fart around with it and I can get right at it 10,000 watts with about 800 watts worth of drive. I don't want to run it that hard for very long. The tubes are not happy. Okay. Let's come over here. Let's look at our input reflect. We're going to get this meter here and this meter here are really important we have in the same shot. This, I think, is amazing. Look at this. Hello, 1, 2, 1, 2, 1, 2, audio. Let's do this too. There's 1,000-ish. Hello. It's almost 4,000 bird. Okay. Which that math tracks. Let's see if we can tune the input tune down a little bit. Hello. 4,500 bird. I'm getting the input down. I want to bring the carrier up. And the reason we got to bring the carrier up is because when I hate. Look, I don't look at other people's videos. I just don't. I don't care anything about them. But when they key up, like let's say an old Arlen video or something like that, he key up and he'd show all the swing and then no carrier. The old time guys, they don't care anything about the swing. They care about what the bird watt meter does. So here, we'll throw a 2,500 watt carrier out there. Hello, audio. It's as hard as I ever want to see this box work while it's here. And that's on a 40 amp breaker, yo. That's what's on the back of the box. Let's zoom on in here. Demonstrated perfect input tune. I need to clean up the pass-through tune on this, but I can do in a second. It's not a big deal. I know how to do that for sure for shizzle. Hello. This box gets down. Good job, Smoke. So now, pull that 10K out, put that 25K back in there because, you know, it's showing us more. No, really, it's doing 13,000, 14,000. It's a difference in meters. It's a difference in elements. It's a different, like if we're running it on an antenna, it might show you a little bit more because there's a little bit of reflag. In this environment that we're working in, we're looking at this here, we're in a perfect ideal universe, right? There's no reflect back from the dummy load. Pardon, a half a watt worth of reflag. Remember, on this scale here, Right there past that 40 is 10 grand, right? Or no, we're on the 25,000 watt scale, so right there at the 10 is 10,000. If we were needle chasers, we'd call that 12,000 watts. I mean, when I look at it from your guys' perspective, let's watch it on the video camera here. It's a good solid 1150, 12,000 watts, peak power. Yes, sir, Bob. I say smokestack, good job, my man. He told me when I talked to him on the phone, Danny is not in the business of lying. He's a stand-up guy. I keep saying Danny, smokestack. When I talked to Smokestack on the phone, he goes, Luke, I put a 2x4 into that thing, and it swung over there 14 to 15,000 peak. And he goes, it was making 4,000 to 5,000 bird. He goes, I put 850 to almost 1,000 watts in it. He goes, that's your max drive. And that's all I needed to hear. I'm like, okay, thanks, Danny. I mean, he hasn't lied. This box has produced everything that you would think would come out of it, right? At least that's how I feel. All that aside, if it was me, and the way I would suggest somebody runs this thing, is they hit it with, 300, 400 watts, slow cruise the thing and have a great day. Take your 2,000 or 3,000 bird and run and have fun. You never have to worry about replacing the tubes, ever. And I mean ever. All right, this is gonna kill you guys, so if you're listening on headphones, you're gonna wanna turn the volume down. But watch what happens with these tubes when you drive them this hard. This is a little bit too much in my opinion. Can't fear the glow, baby. You can't fear the glow. That's funny. I can't wait to listen to the video and see what I've got for audio. I bet the RF is just murdering you guys on that side of the street. If it's not, good job. Hey, right on. We're looking through a piece of plexiglass, and on the other side of that is 10,000 to 12,000 watts worth of power, and it's maybe 6 inches away, so it wouldn't surprise me if the RF's getting into it. Okay. The testing time is over. Let's go and fix our pass-through tune. Let's let everything cool down for a minute. I'm satisfied. And if you're watching this, you should be too. Okay. So, you've been running your amplifier. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2 1 2. The reason I'm saying 800 watts is too much drive is because of this grid meter. We're pinning it in the corner when we modulate. So I'm saying, and the power supply, the amperage over here, but look at our high voltage. It's pretty stiff. It's staying around 6,000. Hello. This is the amplifier's way of screaming at you at the top of your lungs. Stop it! The 4-1000 tubes are a little expensive, but they are available. They are out there. There's a lot of guys that have them. Okay. If you run it with that grid meter pinned in the corner like that, you're going to end up destroying the tubes. They're going to get mad at you. The tubes are going to get mad. They're going to, okay, we quit. All right, so you can do that 10,000 watt thing until you're blue in the face. Back your drive power down. You'll probably end up being around 6,000, 7,000, 8,000-ish watts, where this isn't buried in the corner. You want to keep it back here about, I don't know, around the 8 scale, 800 mils. That's a little bit outside of spec, but around the 800, and it's going to last you for a long time, forever, right? We're not going to mention the fact that this amplifier comes with a spare tube and a spare chimney, just in case you have a problem. So you've been out running your amp. You've been talking on it, been talking to Bob and Cletus and John and Mark and all the guys, and you've been having a blast. You've just been smashing ducks left and right. Now it's time for us to not be talking on the amp. How do we shut it down? I'd really appreciate it if we followed this sequence of events, and we're going to do it for the tube's life and the amplifier's well-being. First, we're going to pull the high voltage off. Then we're going to pull the low voltage off. Now, I have had, while I've been operating this amplifier, these lights stay hung up. The high voltage comes off, but the indicator lamps stay on. And it's this switch here. Just cycle it up and down 2 or 3 times and these lights will shut off. But you're going to pull the high voltage off. Let's start over. First thing you're going to do is put it in standby. Pull your high voltage off, pull your low voltage off, shut your filament off, and we're going to back the filament down to 0. Now you're going to wait. You have to think everything inside the amp is hot. It's hot. It's been running, it's been doing its job, and you have to circulate cool air through the box. Otherwise, you're shutting the box down what they call hot. It's really hard on the tubes. Like, it will suck the life out of the tubes more than anything else. Well, more than driving the shit out of it, of course. When you pull the filament off, you need to let the fan run for at least 5 minutes. My amplifiers that I build over here, they have a circuit in it, which is built off of one timer called a time-off circuit. And it doesn't matter what you do to the switches on the front of the amp. The amp is going to run, well, like a 3000, I'd set it for 6 minutes. And I did that from a data point of turning the amp on, heating it up, taking the tube up to really good saturated operating temperature, and then shutting it down and letting the fan run until it comes down to ambient temperature, and measuring that with my FLIR. You do that 10 times in a row, you'll find that you'll end up with an average around 6 minutes. That allows your filament leads to cool off, that allows your sockets to cool off, that allows your pins to cool off, it allows the tubes to cool off. You strip the heat out of the box. My 40 is a little bit more, it's about 8 minutes. I have it set at 10. You're going to let this run for at least 5 minutes. And when you're done, you can shut the fan off, shut the master switch off. All right? To start the thing, I'm going to put stickers on it. It's going to say master. So 1, 2, fan, 3, filament, 4, variac, 5, high voltage, 6, high, 7. That's it. Then you do it in reverse. So you go 7, 6, 5, 4, 3, 2, 1. Master on, fan on, filament on. Turn the knob up slowly. Bring the tubes up to voltage operating temperature. You want to bring it up to the yellow mark. Do not exceed the yellow mark. Then you're going to bring on the low voltage, bring on the high voltage, bring on the operate switch, and just wait a couple minutes. Let the tubes figure out what they're doing. According to some, and well, known by most, is that the 4-1000 is considered an instant on operation tube. I don't like to push things that hard. It's up to you, the end operator, the guy that ends up owning this, what you want to choose to do. I'd let it sit for a minute or two and then let's go run it. So now we're going to shut down. So 7, 6, 5, 4, 3, oh, pardon me, 3, let it rest for 5 minutes, 2, 1. On, filament, or fan, filament. Slowly run our filament voltages up to the yellow mark. Low volts, high volts, operate, wait a couple minutes, start talking, have fun, enjoy your time on the radio. When you're done, out of operate, high off, down to low, wait for this to bleed down. Pull your filament off, run your filament all the way down, and then turn your fan off, and then master switch. So that's it. That's all there is to it. There's no more magic. This is legit. Legit what it's supposed to be. Okay, real quickly, I just went and looked at the data sheet. And according to it, typical operation for this tube is about 42 milli worth of grid at full saturation. So you're looking at about 84 milliamps. So somewhere between the 8 and the full 1 amp. So we'd be down there at the end of the scale. Okay. So fully chooched out, we want to keep this somewhere below this hash mark here. You don't want to go to 1, you want to stay below it. So here, stay right about at this hash mark here is your maximum amount of drive, which is 6,000 to 7,000 watts. Each one of these tubes will develop roughly 3,900 watts worth of safe usable power. Okay, so 7,500 watts worth of power. This is a screaming box. And for what I'm gonna offer it up for, this is a screaming deal. What you guys are getting here. I gotta put some labels on it. I gotta fix the pass-through tune real quick on it. But other than that, this thing is really ready to go. All the meters check out. The current meter checks out. The grid meter checks out. All the tuners, all that stuff check out. If you buy this, they're going to hear you on the bowl. But I got to tell you, I'm going to sell this with a preference to it. And what I mean by that is I'm not going to sell this to somebody that has never owned a tube amplifier before. I'm not interested in selling this to the guy that's like, man, I got a 2-pillar and Amtron. I want to kick ass on the bowl. Oh no. We got to have a different conversation. And this is kind of a thing that we don't ship. This is something that we either pick up or we hand deliver to each other, right? And I am willing to drive a little ways to meet each other, and that's going to be reflected in the price point as well. To have this box built today, honest to God, is in the department of probably $7,000 to $8,000 with the parts that are in it, the vacuum tuners, the sockets, everything that's in it. $7,000 to $8,000 box with the extra tube and all the other stuff that comes with it. So I need you to keep that in mind when we start to talk about, I understand there's going to be a little bit of delivery issues in this and we're going to have to work through it. It's okay. I'm sensitive to it and we're going to figure it out together. Whoever you are, the person that wants to buy this, because I know somebody at this price point is going to jump on this and they're not going to blink. This is old school badass glass. Cruising 2 pieces of glass. This is a sidebander's dream. This is an AM junkie nightmare right here. And it bums me out my friend Larry never really got to use it. So, okay, let's fix the pass-through tune, and then we'll come back to talk about how much I'm actually asking for this box, because I haven't said it yet. I've just given you guys an idea of what it would cost. And it's realistic. I mean, I've asked 3 different builders that build this kind of stuff, and we all agreed that the price point would be somewhere between, you know, $6,000 and $8,000 without an extra tube, without the extra chimney, without all the extra parts that come with it. So we'll be back. Right. So the RF deck is out. Tubes are out. Let's go down in here and let's take a look at this. So I got to go over this every time I get this piece of equipment out. For the uninitiated, they don't know what they're looking at, so I have to cover this every time. Okay, this is my network analyzer. It is a live update. It updates like 3 or 4 times a second. This is a graph that represents SWR. The color indicator, the red, indicates this point right here, and the green indicates this measurement marker right here. So let's go ahead and we'll take this to 27.250, okay? This represents the center of the graph, which is indicated by this solid line. This is our SWR, this is frequency. Right now we have this reading from 53.9 megahertz to 0 megahertz. This is all the way down here at the very, very bottom of the HF band. What is happening is when we go to talk through the amplifier, otherwise RF power come in from this, or RF power come in from this connection, and to go out to this connection, because the way the relay is set up, there's an SWR passing through the amplifier. This has nothing to do with your antenna. This has nothing to do with your coax length. This all has to do with the wires that are feeding from relay A, which is underneath, which I'm going to show you here in a minute, and relay B. There's an impedance bump. When the RF hits this connector, it goes in through a piece of coax, goes up to another relay, goes up to a couple more connections, then feeds up, goes through this relay, then has to come across this conductor, and then back out to the antenna. What that represents is an SWR of 2.625. Now, how we compensate for that, or help drive down or change, we have to add capacitance in certain spots. Let me show you what I mean. If I take a cap and just touch it to the cabinet, just touch it to the cabinet, we're going to see this graph change dramatically. So we're going to go here to here. So we went from an SWR of 2.63 to 1.75. Now, the reason I took it out of the deck is because placement of the capacitance is very important. Versus here, going from here to here, now going from here to the, now going from here to here, our SWR is now a 1.6. The idea is to get it so that the impedance bump that takes place from the RF coming from the analyzer through a resonant wavelength of coax, through all the connectors, and then out through another resonant wavelength of coax, through the watt meters, and then out through another resonant length of coax, down to the 10,000 watt bird dummy load down here, as this shows next to 0. Why is this important? Your standing wave ratio is, well, it's indicative of a couple different things. It's representative of a couple different things. There's two parts to a radio: your transmit duty cycle and your receive duty cycle. If we're trying to receive on this frequency, and it doesn't matter if it's on the HF band, you know, like 80 meters, 160, so and so and so and so, it doesn't matter. If your pass-through resistance is a standing wave ratio of 2.62 or 65 or whatever, the microvolts that the receiver is working with from your antenna, your receive side of things, is also have to overcome that amount of resistance. So it's both ways. The power that you're putting into it for the driver, let's say that you want to just use this in a, you know, have the amplifier off and just talk on your driver, you're having to overcome an SWR in the box, in the pass-through circuit, of a 2.65, and then you get to go to your antenna. But you'll never see it unless you got a watt meter between your driver and your big box, which you do have to run this amplifier. You'll see it though in your receive. That micro voltage, now we're talking 1,000 watts, 500 watts that have got to go through this relay in the standby mode. Your receive is working on microvolts, okay, millionths of a volt. That resistance is going to cost you a whole bunch of receive signal. Okay, so now my mission here is that I have to add capacitors on both sides of the deck. I have to add caps. Probably going to throw one in here. It's a 1.6 from a 2.6. And then on the bottom side, we're going to have to add some capacitors as well. And we've got to get this to where this graph is all the way down here on the bottom, so that the RF coming from the antenna can feed through the relay and out to your radio with the least amount of resistance as possible. So you're not sacrificing receive, and when you go to transmit, you can talk smoothly through the amplifier. And why I'm here, because like I said, this deck is sat for a long period of time. I'm also going to varnish all the relay contacts. That way when the relay opens and closes, it's got a nice clean surface. There's no arc burn, no carbon score, nothing. To guarantee this thing is going to work the best that it can. Let me go tinker with this. We'll be right back. Okay, so the coax that was in here, the way this was fed was, this was the center conductor here, and then it grounded to the cabinet. You'll find that you'll have a lot better impedance bump if you bring the coax directly to the cabinet. So I went ahead and replaced this with a piece of RG400, and it came right down to the cabinet, and then I came up to a new eyelet that, of course, the wire goes through and you twist in place and then you solder it. First you have a physical and then mechanical connection, right? Well, that helped quite a bit. That took it from 2.63 just by doing that. Took it down to a 2.2. So we're talking, this kind of setup, we have to just shave little bits off at a time until we get to where we want to be. So it comes through this connection, goes through this wire, and it goes through this contact, okay, goes down this tab, and goes to this tab, which has also got a mechanical connection. So then we removed, there was a piece of red Teflon that was in there. We removed it. We had to add 20 puff worth of capacitance here. Because remember, we've just had an inductor, so now we're going to bump it with a piece of a little bit of capacitance, help knock that down. Once again, RG400 to the top of the cabinet. On the top of the cabinet, where it makes contact with the relay on the other side, we had to add 50 puff worth of capacitance. The end result is this. .197, so 1.2 or below. Now this is going to change a little bit when it comes to your coax length. This is one of the things that everybody is all excited about, and I probably get 15 questions a week about what do you think about tuned coax jumpers? They have their place, they do their thing, but this is the tell-all right here. So we went from having like a 2.8, 2.6 to a 1.2 pass-through tune. As you can see, as we go up in frequency over here with the green cursor, SWR starts to climb. When you get really good at reading this stupid thing, you'll be able to pull out what all this other data means. And if you guys choose to buy, you don't need this $19,000 analyzer like what I've got here to do this. You can do this with an AA30. You can do this with a 250B, MFJ 250B. It's just not going to update as quickly, and the graphics aren't as pretty. I bought this because it's also an RF generator, it's also a tone generator, it's a demodulator, it's a bunch of different things. It's a full-up handheld blown network analyzer. I have two of them, so I can put signal in and have signal come out, and I can measure how it changes the signal. I bought this when I was doing the LDMOS stuff. Sure made learning about it a lot easier. Anyhow, I think that this is a good pass-through tune. This is about as best as we're going to be able to get with the component placement and whatnot. So all I have to do is tweak that a little bit to take all that reflect out. I'm going to do it. Okay, so now to start the process of putting the RF deck back into the cabinet, which is not that big of a deal. I got to bolt the bottom on with the blower, shoehorn it back in the cabinet, and hook all the connectors back up. It's okay. I took lots of pictures. I'll be fine. Okay, before I run away, let's take a minute and let's look at all of this. So we have the striker hooked up. So coax comes down, comes to the input connector, and it's going out to the dummy load now. Let's see what we got going on for pass-through tune. So we're going to bang about 80 watts through it. And I want to show you, because if you guys remember in the previous segment, I showed this same 80 watts had like 2 or 3 watts coming back, and the front of the meter was showing an SWRF2 with just radio drive. Check this out. Hello, 1 2 1 2. Hello, 1 2 1 2 1 2. Hello, audio 1 2 1 2. So instead of having 3 and 4 watts coming back, now we've got less than a tenth. This is reading 1 bar, and that's literally half a square up there on that thing. So I guess it'd be like 1/20th of a watt or whatever. That to me is a workable pass-through tune. That means you're not sacrificing any receive, and you also don't have to worry about damaging your driver when you're talking through the box. So, okay, problem 100% fixed and now tested. Let's put it all back together. Let's take a few minutes. Let's put some labels on the front of things for the sequence of deals, and we'll call it a day. Well, in loving memory of my friend Larry Braden. Okay, so once you get this thing running on your own, you can go ahead and remove the number stickers if you want. But remember, we're going to go 1, 2, 3. And we take and we turn this knob up slowly. That's number 4. Okay. We come up here and go 5, 6, 7. That's after you get it tuned out. Then when we shut everything down, 7, 6, 5, 4, 3, and you got to wait for 5 minutes. 2, 1. That's simple. Now, this is not perfect, and I know this. And the other thing that I have to be sensitive to is the fact that this thing has to be picked up. I don't feel comfortable putting this in a wood crate and having it shipped across the United States. So either I'm going to have to drive for 10 hours one direction and meet somebody halfway or something, or I'm going to have to bring it and deliver it in California or something. We're going to figure out something. And I know that, and in the same breath, you know, if I got to drag this thing halfway across the country, we're going to have to work out a little bit of gas money compensation. But I'll do it because I love my friend Larry, and I just want to see another person get on the air and straight. So, you know, the tubes, the sockets, the blowers, the filter caps, the cabinet, all that kind of stuff, that all adds up. And that would easily be in the $5,000 to $6,000 range at this point in today's day and age. Plus the extra tube, plus the extra chimney. I'm asking $3,500 on this, period. And it cannot go to the guy that only has a 2-pill, or has got an Amtron, or has got RG8X mini coax or whatever. We're going to have a conversation, whoever you are, and you're going to tell me about your history with radio. You're going to explain to me that you understand what input tune is and how to properly peak out an amplifier. Ideally, this would be one of these things that I bring and I personally hand deliver and help you put in your house, and we plug it in. It's going to need a 220 50 amp outlet with $3,500. And then we'll figure out the rest when we get down the road. It's pretty straightforward, very clear what it is, and I can't wait for it to go to a new home. Once again, I want to thank the Patreons for allowing me to be able to do this entire hour video without having any commercial interruptions from YouTube. The Patreon guys have known about this now for weeks. If you're not part of the Patreon team yet, you might want to think about coming and joining. I put a post up every single day and show them what I'm working on or what I'm doing. Usually it's 3 or 4 posts per day. Everything that goes up for sale goes to them first, and if nobody in the group wants it, then it comes out to the YouTube group. So it's just food to think about, and something else to consider. I want to shout out to Penna, XS, Siglent, Mechman, Bird, Coaxial Dynamics. I want to give a big shout out to good old Smokestack. Danny, you're a good dude. Thanks for talking with me about the box. Thanks for giving me the history about the equipment. You did a great job building this thing. I understand. This thing works great. It does 10,000 watts on one slug, and it does 12 or 13,000 watts peak on another, and it's 5,000 bird box. Back it down, enjoy 8,000, 9,000 watts, and it's going to last you forever. Forever. Gentlemen, I say thank you, and I am officially done. This is the last piece of equipment from my friend's estate. Well, there might be 2 more, but they're small things. But I'm officially done. I appreciate everybody that's been tuning in and following along with this entire series. There's a whole lot more stuff coming. A whole lot more repairs. I can't wait to jump into them. So on that note, gentlemen, I say thank you. Big shout out to every single one of you guys. Please give me a thumbs up, make a comment in the comment selection. It helps with the YouTube algorithm. If you enjoyed what you've seen here, give me a thumbs up or at least make a comment. Appreciate you, gentlemen. I'll see ya. Click, click.